Welcome, and thank you for joining this webinar, Wireless Driving the Automotive Machine to Platform Transformation Executive Summary, prepared by Albert Research Team. Today, we're exploring one of the most profound shifts happening in the automotive world, the transformation of vehicles from mechanical machines into intelligent, software-defined platforms powered by wireless technologies.
What are the biggest impacts we're seeing today? Maybe start with the core SDV concept, over-the-air updates.
OTA updates are really the lifeblood of the software-defined vehicle after it's sold. They enable continuous improvement. Think security patches delivered quickly, bug fixes without a trip to the dealer, even adding new features or improving performance over time. The business case is incredibly strong. You mentioned recalls earlier back in 2015. Something like 15% of U.S. vehicle safety recalls were purely due to software issues.
And a physical recall for software is hugely expensive and inconvenient.
OTA turns that into a relatively seamless, quick digital fix pushed out over the cellular network. Because of this efficiency and value, adoption is skyrocketing. Projections show OTA capability jumping from maybe 24% of new vehicles today to around 78% by 2030. This covers both SOTA software OTA for things like infotainment and the more critical FOTA firmware OTA for powertrain braking and ADAS controllers.
And beyond fixing problems, OTA is the key that unlocks new business models for automakers.
Absolutely. It enables feature monetization after the initial sale. Increasingly, cars might ship with certain hardware capabilities built in, but they're activated or enhanced through software. So automakers can offer subscriptions for things like, say, advanced driver assist features, maybe heated seats in some markets, or even temporary performance boosts.
Pay-as-you-go features for your car.
Essentially, yes. It allows the vehicle's value proposition to evolve over its lifetime. Telematics data suggests connectivity subscriptions alone could generate around $120 per vehicle per year on average. This transforms the business model from a single hardware sale to an ongoing service relationship, all tied to that wireless link.
How does all this connectivity, particularly V2X, enhance safety in ADAS beyond what onboard sensors can do?
V2X provides that crucial layer of non-line-of-sight awareness. Even the best radar or LiDAR can't see through buildings or around sharp curves. V2X can. It allows cars to share warnings about hazards ahead, sudden braking, black ice reported by another car, and emergency vehicle approaching. It extends the vehicle's perception bubble significantly.
This is becoming part of safety ratings now.
It is. The benchmarks are moving fast. Euro NCAP, for example, is set to start assessing cloud event sharing in 2026. This means a car's ability to receive hazard warnings from the cloud data, likely uploaded by other V2X-equipped vehicles or infrastructure, will actually contribute to its star rating. That capability relies entirely on robust V2N cellular connectivity. And alongside V2X, we have those local wireless sensors we discussed. UWB for child presence detection meeting mandates, TPMS for tire safety, all feeding crucial data into the vehicle's safety and ADAS decision-making system.
Moving to user experience, the digital key is a great example of that layered technology approach you mentioned.
It really is. It perfectly illustrates why you need that toolkit. The digital key typically uses Bluetooth for the initial handshake and pairing with your smartphone. Then it uses UWB for the secure, precise distance measurement to prevent those relay attacks we talked about, ensuring you're actually next to the car. And finally, NFC provides that short-range, battery-off backup.
Convenience plus security through multiple layers.
Exactly. One technology alone couldn't provide the same combination of ease of use, robustness, and security.
Using all this data streaming for maintenance and operations, how does that work?
This is where predictive maintenance and edge intelligence come in. For predictive maintenance, you use the aggregated telematics and diagnostic data that is streamed back, perhaps less frequently or in summary form. By analyzing trends across thousands of vehicles, manufacturers can identify patterns that predict component failure before it happens. Maybe track subtle changes in vibration, temperature, or performance metrics. These systems can potentially cut maintenance costs by up to 30% and boost vehicle uptime by scheduling repairs proactively before a part fails catastrophically on the road. We mentioned autonomous vehicles generating potentially terabytes of data daily. Streaming all of that raw sensor data to the cloud for real-time processing just isn't feasible or efficient for many critical functions.
The latency would be too high for immediate decisions.
Right, so you need edge computing. This means putting significant processing power and AI capabilities within the vehicle itself. These edge processors can analyze raw sensor data locally, make low-latency decisions for ADAS or vehicle control, and only send summarized or critical information up to the cloud.
So edge handles the immediate needs.
So what does this all mean? The message is clear. Wireless is no longer an add-on. It is the infrastructure of modern automotive value. If you take away one thing from this review, let it be this. Wireless is now the central nervous system of the automotive industry, and mastering it is essential to driving the future of mobility. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.